Can y'all see that okay?
Yes.
Okay, so today we're going to be covering Chapter 7. So we're going to be talking about cattle, so beef cattle and dairy cattle. So just quickly what we're going to go over, I'm going to give you just an introduction to cattle, talk a little bit about their domestication and history, their biology, and we're going to talk some specifics about beef and dairy cattle. So just to give you a little introduction, most beef cattle and cattle in general are the most important livestock species in terms of both their value and the weight of their products. So meat, milk, and then other products. And then ruminants consume fibrous plants that can't be digested by non-ruminants. So we kind of talked in an earlier lecture about how livestock animals can kind of take things that humans can't digest and turn them into valuable. So cattle are really classified into two main species. So there's Bos taurus, which is the European breeds, and Bos indicus, which is the Indian breeds. And so I'm going to go a little bit more into the differences between those two later and kind of show you which species fall under each category. And there's complete fertility between the species. So it's not like if the mule is not fertile, there is complete fertility between these two species of cattle. So a little bit about Bos taurus breeds. They're typically maternal and or terminal breeds, which means that a lot of times their offspring is going to go to market. And they have excellent production qualities in more temperate climates. So kind of like where you all live, they would do really well. And also, in this area of North Carolina. They're known for really good carcass traits. So they have really good marbling and tenderness and yield. Does anyone know what marbling is, what that term describes?
The fat.
Right, yeah, the intramuscular fat, exactly. So marbling is used to determine meat quality. So good job. So then compared to Bos indicus are more heat tolerant and they have increased disease and parasite resistance. And so they have better production in subtropical climates. So they're kind of popular in India, some in South America, areas where you kind of have that more tropical climate. However, some negative attributes of the Bos indicus is that they have an older age at puberty, so it takes them a little bit longer. And then they have decreased carcass quality, and there can be, that's just like handling stress issues, so they can be a little bit harder to handle than the Bos taurus breed. Well, just a little bit about domestication and history. We've kind of touched on this before in the domestication lecture. So there were two separate domestications of the now extinct wild ox, which was called the Bos primigenius, I think is how you say that. And so it was the first domestication was around 5800 BC in the Fertile Crescent, which you remember from that other lecture, pretty much everything happened in the Fertile Crescent. And then the second happened around 2500 BC in the Indian subcontinent. So the Indian subcontinent is kind of where the Bos indicus breeds would have kind of come from. And then Christopher Columbus brought cattle to the Americas and the West Indies in 1493. So just a picture of the external anatomy of the cow. Again, I'm not going to expect you to know all of these at all, but just for your information, if you want to know it, I just put this on here just so you would have it. We'll talk a little bit about other body parts a little bit later when they come into play with things like body condition score and things like that. So cattle have 60 chromosomes, so they have 29 pairs, and there's been tremendous progress in mapping their genome and actually, figuring out which genes are responsible for which codes for that. And then, like other species, improvements in cattle genetics resulted in major improvements in milk and meat production, milk composition, and the quality of the milk and meat products that are being produced. So sire selection, which if you remember, sire is the father. So that selection is based on genetics and then the heritability of the traits. So how likely is it that those traits are going to be passed down to the offspring? So different traits are more heritable than others. So that's important to look that. It may have a really good trait, but the trait may not be very heritable, which means that the chance it's going to actually be passed on is pretty low.
I have a question on that slide. How is it 60 chromosomes and only 29 pair?
So that's not counting the sex chromosome.
Okay.
Oh, okay.
So stress can be a big thing in cattle, and management techniques, if you're not doing it properly, can evoke a stress response in cattle. Even some things that you have to do with cattle that you can't really avoid could evoke a stress response. So things like ear tagging, branding, or tail docking, which is done more in dairy cattle, can cause a stress response. So it's really important to make sure that you're handling animals in the best way possible and not stressing them out, because it will affect their meat quality and things like that, especially when animals are being transported to the slaughterhouse and things like that and then unloaded. You want to really make sure that they are not being stressed, because their meat quality will be really bad and you may not get as much. That's really important to think about. So a little bit about cattle reproduction. So in dairy, the primary goal is milk, obviously. So you want high milk production from your cows that are lactating, and then you also want to be producing replacement heifers that can come in and replace those that are getting kind of out to several lactations and are going to be called soon. And then in beef, the primary goal is to produce numbers of offspring for meat, and then milk production, which can provide early nutrition for the calves. So that milk production is a focus, but the main focus of beef production obviously is beef. So just a little bit of the differences there. So the gestation in cattle is between 279 and 290 days, and usually there's a single calf. Sometimes there can be twins. I think I've actually seen one case where there were three, which is crazy. Normally it's one. So just to kind of continue a little bit about the reproduction, bulls will identify cows in heat by smell. So if you're using a natural mating system and you're not using artificial insemination, and you do have a bull in there, they will be able to smell when cows come into heat. So the estrus cycle in cows consists of a growing follicle that's on her ovary, so that will that's how that process gets started. And cattle are polyestrous, and so that means that they actually will cycle throughout the year. And their cycle length is 21 days when it does. So it takes 21 days for the follicle to develop and that whole process to happen. And so then age at puberty is 6 to 12 months, and that's a really wide range because that varies with breed. So like we said, it takes the Bos Indicus breeds a little bit longer to mature. So there is a wide range there. So when you're looking to start breeding your cattle, make sure that you're familiar with the breed that you're using, obviously, and when they really reach puberty, because it could vary compared to another species. And then gestation length, again, we already talked about. So how do you detect when one of the cows is in heat? So one, behavior is going to change. So the cows will have increased vocalization and activity. They'll seem kind of restless. They'll be making a lot of noise. A lot of times they'll attempt to mount or ride other cows. And then they will stand to be mounted is a big one. So if a bull approaches, if a cow is in heat, she will stand there. And that's a good spot. As far as what you can see physically, they'll have a swollen vulva with a clear mucus discharge, and that'll be kind of red, so you can see a difference compared to cows that are not in heat, and that will tell you that she is in fact in heat. So as far as breeding, so cattle should be inseminated during the last half of what we call standing heat, which is approximately 12 hours after the onset of heat. So to make this simple, the way that I learned it, the way that I was taught, is the AM/PM rule. So if the cow is seen in heat in the morning, then you're going to inseminate in the evening or that night. And then the opposite, if you notice the cow goes into heat at night, you're going to inseminate the next morning. So that's just an easy way to kind of keep track of it. And you don't really need to know the specifics of this chart at the bottom. I just kind of have that on there if people are really, really interested in it. I just want to have the information there. But that just kind of shows you when standing heat occurs and then the optimum time to inseminate. as you can see, is not at the very beginning. So as soon as you see her in heat, you don't need to run out there, because based on when she's going to ovulate, you have, you know, a good 12 hours before you really need to inseminate. And a lot of people, just if you want to kind of really make sure that you're doing it at the proper time, I know some people will inseminate twice after. So like if she comes into heat in the morning, you might inseminate that night and then also the next morning. But that just depends on how much semen you want to use and how, you know, accurate you really want to try to be. Because the sperm life, as you can see in the female tracts, it can actually live there for a while. So it hangs out for a while. So if you do it kind of on that timeline, then it should be there when the ovum is released, the egg is released. So that's just kind of how you can think about breeding there in your kind of time frame. Any questions on that? Okay. So like I said, there's normally one calf per pregnancy. And then some cows, I'm sure a lot of you probably have experienced, will have difficulty calving, especially if they're heifers and it's their first time calving. They might have more difficulties. And so difficulty calving is this term dystocia. That's the term that's used to kind of describe that. The mammary glands, or the udder, consist of 4 separate glands called quarters. And there's a teat that hangs down from each quarter. So I'm sure any of you that have seen a cow are very familiar with that. And then another important thing that kind of goes along with cattle reproduction and making sure calves get a good start is called colostrum. And that's basically the first milk. So the cow will start producing this immediately before the birth of the calf, and it's extremely important that the calf gets this colostrum, or first milk, because that first milk contains antibodies to protect the newborn from disease. So it's actually a way for the calf to get passive immunity from the mother until it has a chance to really build up its own immune system. So that is super, super important. So I know some people in the past, my uncle's a farmer, and he had a situation where his calf, the cow would not let it even get milk the first time. And so he actually had colostrum that he had saved from other cows in the event that that happened, so that that calf was able to get some of that first milk, because it is really, really important. And it's not really something that can be replicated with a milk replacer formula or anything like that. Formula feeding is okay after that point, but the colostrum is really, really vital. So this is just a picture, sorry, I apologize, it looks like it's a little blurry, of the ruminant digestive system, and I'm going to kind of zoom in on this and really focus on it a little better after this. This is just kind of the overall picture. So you have the mouth and then the esophagus, and so then the difference between a ruminant and a non-ruminant, which we're going to go into more detail, is that one has a rumen with other compartments. So they have 4 compartments in their stomach. So don't be confused in saying that they have 4 stomachs. A lot of people will make that, they'll say that they have 4 stomachs, and it's not true. They have 1 stomach, but they have 4 compartments. So then you have your small intestine and your large intestine. So just to give you a little bit better picture of the ruminant stomach, so like I said, it has 4 compartments. So all of this is the stomach. And so you have the rumen, which is going to be the largest part, so that's this entire part, and then the reticulum, the omasum, and the abomasum. And so we're going to talk a little bit about what each of those is. So just to kind of show you what the inside of a ruminant stomach looks like, each section or compartment does kind of have its own characteristics and its own function. So ruminants are actually pretty efficient at digesting their feed, more so than monogastrics, I would say. So here we have the rumen, which is the largest part. So the rumen is going to be pretty much where food comes in first. And it has these papillae-like structures, which we'll talk about a little bit in a second. The reticulum has this, what I learned, it was kind of like a honeycomb structure. That term kind of helped me visualize it and stuck in my head because it does look like a honeycomb. And then the omasum is folds, kind of like pages in a book. It's just a lot of different folds and layers. And then the abomasum is considered their true stomach. So the abomasum is kind of what the inside of our stomach would look like, or a pig's stomach. So that's like the site of chemical digestion. And so that's what they kind of share with us. So we'll talk about each of those in a little bit more detail. So the rumen is extremely important for ruminants and cattle. So the rumen has microorganisms that break down cellulose, and they can produce volatile fatty acids. So if you remember when we talked about the horse, how horses were hind-gut fermenters because they had the microbes in their cecum that would produce these. So ruminants, it's the same setup. They just have them in the rumen. And it's actually a more efficient system because in cattle, the volatile fatty acids are produced before the rest of the digestive tract, so they can actually be absorbed. Whereas in the horse, they're kind of produced after most of the absorption has already taken place, so a lot of them are not really. So that's a big difference between ruminants and monogastric. So the main volatile fatty acids are acetic, propionic, and butyric acids. So there are a lot of other fatty acids, but those are really the main two that you should be familiar with. Acetic is a really, really big one. And so they can provide energy for the animal. So the volatile fatty acids are actually largely absorbed in the rumen. And so like I said, it's really efficient because the rumen is pretty much once the food gets there, that's like the first site. So you still have the whole rest of the fat and they're already absorbing these volatile fatty acids. So volatile fatty acids can actually provide 60 to 80% of the energy requirements for the animal, which is pretty huge. So those microbes in the rumen are extremely important to break down that cycle. So microbial digestion is why ruminants can be maintained on a diet of rough food fiber. So that's why they can eat things like hay and silage and things that you would not feed to a pig or a chicken, because a pig or a chicken would not be able to digest that very well. And then in the rumen, like I showed you in that picture, they have papillae, which are the tiny projections that actually increase the surface area for absorption. Because if you kind of have flat stomach, that's really all the area that you can absorb. But if you have the papillae, then it really increases the area for nutrients to be absorbed. Does that make sense?
Which, did you mention that, it's basically fermentation that's going on in the rumen at this point?
Yeah, essentially. So it's fermentation. Yeah.
Yeah, I didn't know if you mentioned that and I zoned out or not. But for those of you that
I didn't say,
y'all Patrick Henry that are near Franklin County, y'all know a lot about fermentation. But that in essence is what's going on there. And it's going to generate an interesting amount of heat in there while it's happening too.
Yeah, for sure. Yeah, no, thank you. I didn't mention that specific term actually, but yeah, you're exactly right. It's fermentation.
Just try to help them get their minds around things.
Yeah, no, feel free to jump in.
Yeah, this is actually something I remembered from tech.
Yeah.
Not much, but I did remember that one.
Yeah, I'm trying to think back to my intro class and all the things that we talked about and add that to slides. So the reticulum is actually connected to the rumen, and so it can kind of be called the rumen reticulum in a way. So there's kind of a little bit of a flap that's kind of between the rumen and the reticulum. So you can kind of bounce back and forth between those two. So it typically kind of enters the rumen first. Some of it may drop into the reticulum. So really when food comes in, the heavy or dense feed will kind of fall down into this compartment, and some of the other feed will kind of go into the rumen. So another problem with that is that metal objects that are eaten by the cow, anything that was in your cow pasture, anything like that, nails, anything will fall into the reticulum. And that can be a big problem because the reticulum lies really close to the heart. And so this can actually cause what's known as hardware disease. So that's when nails and other sharp objects get into the tissue and will actually cause an infection. So a good way to prevent this is to use a magnet that's been designated for this purpose in the reticulum. So if you feed it to the cow, it's heavy and it could drop into the reticulum. And you can see in this picture, I thought was kind of cool, that was a magnet that, obviously hasn't been used. And then on the right, you have this magnet that was removed, maybe during slaughter or something like that. And you can see how much it actually picked up that the animal ate. And
how would a cow even begin to start eating metal objects?
honestly, I mean, I don't know how they would just somehow they do.
It'll depend a little on the type of feed that they get. If they're just grazing, they won't be as likely to do that. But a lot of these animals are fed prepared feed, like you said, from a trough, and that can be a product of any one of a number of things that have made it through a manufacturing process.
Right. Yeah. Yeah. Thank you, John. Yeah. So it's definitely something to be aware of. When I was at Tech, they actually said that you have to eat more metal than you actually would realize and think. So as you can see on that magnet, there was quite a bit. And if that had gotten through the rest of the tract, that could have been really, really bad. So that's just a really important thing to think about. And like John said, depending on how your cows are fed, depending on the system, you may want to consider magnets versus not.
So how do you remove the, if you found out your cow had eaten something? Or how would you remove it?
So like if you know that your cow ate something, and then how would you get the magnet out?
Yes.
So from my understanding, it's pretty much in there until the cow goes to slaughter. I would, John can correct me on that if that's not right. But even if you know that they ate something, the purpose of the magnet is to grab that metal object and keep it in the reticulum and keep it from kind of free floating, because that magnet is heavy, so it will stay in the reticulum. And so if it catches the object, then it's fine because it will be bound to that magnet. It won't be floating around really causing any harm to the animal. So it's kind of really a good preventative measure to have in there. That way, if you find out that they did eat something, you can trust that the magnet has it under control, hopefully.
Oh, okay.
Yeah.
Thank you.
Do you serve magnets offenders?
No.
Okay.
So the next section that we're going to talk about of the stomach is the omasum. And this section contains many different folds, kind of leaves of tissue. So I like to think of it like pages in a book. So the primary function of the omasum is the absorption of liquids. So like water and then milk in calves. So it's extremely important section in calves, compartment of the stomach, because they will be on a pretty much all liquid diet. So the omasum is going to be really important for absorbing that milk. So the feed material between the leaves will actually be drier than other compartments, because once the feed is between those leaves, all of the water is really being absorbed out. And so that feed will be really dry at that point. So then the fourth and last compartment of the ruminant stomach is the abomasum. And so it's kind of usually called the true stomach, because that's the stomach that we're most familiar with, the type of stomach we're most familiar with in monogastrics. So it's comparable to the stomach of non-ruminants. So it's exactly like our stomachs and pigs and things like that. So it has a glandular lining. And so the primary function of the abomasum is chemical digestion. So feed is going to be broken down by hydrochloric acid and other digestive enzymes. So that's a lot of what's going on there, is that actual chemical digestion after the fermentation has already occurred in the room. Any questions on that? So just like in any other species, the feeds must meet the nutritional requirements of the animal. So ration formulation for cattle is really important, and it involves knowledge of a lot of different things. So you need to know the requirements of the animal, and requirements also depend on the stage of the animal, what your goals are, and then the availability of different nutrients, or even the availability of certain feeds. Like there might be a particular crop or something that you want to feed that maybe you would have to pay to get transported somewhere. It might not be readily available in your area. Quality of the feeds that you're getting and the ingredients, or the hay. Palatability, which just means how it tastes. Some animals can be rather selective. So palatability of the feed is really important because if it doesn't taste good, they're not going to want to eat it. Like if we don't think something tastes good, we don't want to eat it. So that's important to consider. Digestibility is also another thing that needs to be thought about. So just because you feed a certain feed, it doesn't mean that all of that feed is actually completely digestible to the animal. So that's really important. And then the cost of ingredients. So obviously, you want to try to make your production system, kind of as low cost as possible, so you can get the best return on investment with that. So if you have two feed ingredients that are similar and one of them costs a lot less, you might want to look at using that feed ingredient. So cost is always really important to consider there. So the nutrients that are required are just like other species. So energy, nitrogen, protein, minerals, vitamins, and water. And nutrients can be supplied from grazing on a pasture or ranch land, or also feeding a high corn concentrated diet. So it depends on your production system and whether you have, all grass-fed cattle or whether you also want to supplement. So a little bit about beef cattle in the U.S. So the U.S. beef industry produced about $67 billion in 2016. And there were about 1 million farms and ranches that were selling cattle and or calves. And then consumption of beef in the U.S. was 24.8 billion pounds in 2015. So these are a little bit higher than the numbers that are given in the book. I believe those numbers were for 2005 or 2007. So these are just a little bit more updated, so those numbers have increased. And then exports of U.S. beef, there were 3.6 billion pounds, which equaled $5.6 billion of exports in 2000. So it's quite a large industry. Just some things about U.S. beef production. There have been some structural changes. The number of operations is decreasing, but there are more large producers kind of happening. And I think we talked a little bit about that in previous lectures, and that's kind of happening with pigs as well, where the number of farms is kind of increasing, but there are more large producers. So production by state, cattle are raised for beef in nearly every state of the U.S., but the top 3 beef cattle producing states are Texas, Kansas, and Nebraska. So something that has really impacted the beef industry, more so in Europe, but it did have an impact here, is BSE. So BSE is actually, it stands for bovine spongiform encephalopathy. It's kind of hard to say, which is why it's better to just say BSE. So just you can know that term, but BSE is a lot easier. It rolls off the tongue better. And this is commonly known as mad cow disease. So BSE is kind of just a more scientific name for it, but I'm sure most of you have heard of mad cow disease before. So that's what that is. So BSE is a fatal neurodegenerative disease in cattle, and it's transmissible through processed animal products from infected animals, especially any products that contain brain or spinal cord tissue. And so this actually reduced beef exports in 2004 because obviously if you have an outbreak of mad cow disease, you can't be exporting that beef. So there are, given that it's been a problem in the past, there are now regulations in place to help prevent BSE. For example, you can't really feed products from ruminants directly to other ruminants. That's a really, really big one. And if you, for example, in a feed mill that's making feed, if they've used ruminant products, they would have to make sure that no contamination is happening if they are about to make a cattle feed. So they may have made a feed for another type of species, but they would need to make sure that everything is clean and ready to go and that there's no ruminant products that could get contaminated into a diet that's going to cattle.
Leanne, you might want to define what ruminant products are, because I don't think many of our folks in here would know what that is.
Okay. So like a good example of ruminant product would be meat and bone meal. So a lot of times things that are kind of left over once the major cuts of the animal have been sold for human consumption, a lot of that will kind of be mixed together and then ground up, and it can be served as what's termed meat and bone meal, which can be really nutritional. Geez, I'm having like a really bad brain problem today. But anyway, so that could be fed to pigs, but you wouldn't really want to feed that to other ruminants because if an animal was infected and there's any sort of brain or spinal cord material in that meat and bone meal that's fed back to a cow, it can actually cause them to get the disease. So a lot of times I know that actually cattle feed is produced at feed mills separate from other species, from mills that make other species to prevent that. So is that kind of a better explanation? Does everybody understand that?
Yeah.
It's a product of generally formulated feeds. And a lot of cattle feed may have ground corn, it may have silage, it may have ground hay, and to increase the protein levels, they'll put some of these ruminant products in, bone meal and things of that type, to balance. And I'm sure later in the semester you're going to talk about formulating feeds, and that's one of the things that we talked about.
Right. Yeah. Later in the nutrition, we'll kind of talk more about that. So there are three major segments of U.S. beef production. So you have your cow-calf producers, and they typically have an average of 40 cows per farm on the 800,000 herds with beef cows and cows. So cow-calf systems require less labor and investment in equipment and facilities than other types, but they do require a very large investment in land. Then you have purebred breeders, where calves are reared to provide replacement bulls, with some cows or heifers for cow-calf operations. So you're really looking at replacing and then purebred breeders kind of continued. They're responsible for the genetic improvements in the beef breeds. So obviously they're going to be selecting for animals that have desirable traits. And then costs are high as it takes years to develop a good high quality herd. Because if you're selecting animals for certain traits and you make a wrong decision and you get a bad trait, it's going to take, you're going to have to figure out your genetics and maybe use another animal. But, to raise cattle in the gestation length, it takes a while. So it can take a long time to really get to a generation of animals that are a really high quality herd. So that's one thing with the breeders. And then another segment is cattle feeders. So the goal is high quality finished cattle for the slaughter market in the shortest time possible. And the costs are greater than cow-calf operation. So we kind of already mentioned this, but just to kind of show you again, so some changes that have happened in the U.S. beef industry. The number of beef operations is decreasing and moving to more large producers. However, the rate of change is a little bit slower than other sectors such as pork production. So this is happening a little bit more rapidly in pork. But you can just see on this graph that the number of all cattle and beef operations in the U.S. Has been declining, and beef specifically, those lines kind of follow the same pattern. So we talked about purebred breeders and how they want to improve their genetics. So how do you select the animals that you're actually going to breed? So selection of beef animals involves things like production traits. You want to look at growth and feed efficiency. How well do those animals grow? How efficient are they on the type of feed that I'm going to be using? Carcass quality, so muscling, condition, frame, and meat quality. So how much meat is that animal actually going to yield at slaughter? What percentage of that animal at slaughter is going to be saleable product? Those kinds of things. And then also quality, because that will impact the grade that meat is given, whether it's prime or select or anything like that. So it'll really impact how much money you get for that animal. So carcass quality is really important. Performance records of the sire and the dam. Obviously, if you don't, if you're going to be using certain sires in certain dams, you need to know how well they performed during their lifetime. Because if you didn't keep track of that, then you don't really know if they were growing well or had good performance traits or not. So it's really important to keep performance records so that you can go back and see which cows you want to breed. And then conformation, which is pretty much meat yield, so based on the skeleton, muscling, and then amount of fat on the live animal. And then progeny records. So again, record keeping is really, really key. You want to keep records of not only how a certain animal performed, but then if they were actually bred, look at how their offspring performed over the course of their lives as well. And that'll kind of give you an idea if the traits are being passed down or not. And then another more scientific approach is that there are DNA markers for desired trait. So a lot of people that provide semen for like artificial insemination may have done that. So they can kind of give you more of an explanation of whether or not an animal has the desired traits. So body condition score, we talked about body condition score in horses already. Very same concept. So in cattle, it typically ranges from 1 to 9, so similar to horses, with 1 being very thin and then 9 is very obese. So also pretty much just like horses, an ideal body condition score is between 5 and 6. And so we talked about it earlier, and it's a really big thing, and it's really important because it really helps you determine your nutritional management of your animals. And it's also really important because body condition score is linked to reproductive performance. So if you have a cow or a heifer that you're going to breed and she has a really low or too high body condition score, you may have trouble actually getting her pregnant and getting her to carry that to term, and just other reproductive problems that can come from that. So body condition score is really important in that way. It's an easy visual thing you can go out and do. And it will kind of also help you keep track of, like, if you go out one day and your animal's a 6, and then let's say a month from then, you know, it's down to a 4, you might see if that animal is sick or things like that. So it's just kind of really, it's an easy tool and it's very useful just to kind of keep track of things. Any questions on this? So these pictures just kind of show you some of the areas that you would look at when you're going to do a body condition score. So can you see the pin bone, tailhead, hip bone, back, ribs, and things like that. So obviously on beef cows, you wouldn't really want to see their hip bone sticking out. On dairy cattle, though, you might, just because body condition scoring is a little bit different, because I'm sure if you've ever seen a dairy cow compared to a beef cow, they look a lot skinnier. And it's just because of the different breeds and what they're really being used for. So there are more than 50 breeds in the U.S. The most common are Angus, Limousin, Simmental, Hereford, Cold Hereford, and Charolais. So we're going to talk a little bit about a few of the. So British breeds are, that includes the Angus, and you have black and with Angus, Shorthorn and Hereford, and you have horned and cold Herefords, which we'll talk a little bit more about. So compared to the continental breeds, which would be like the Charolais, British breeds are smaller in mature size, and they reach mature size at an early age. They have slightly less growth potential, but they do have great fertility and calving ease, which are really, really important. And they have lower carcass yield, so they will have lower amounts of meat that they actually produce, but better quality grades. So again, it just depends on the goals of your system. So the continental breeds, like I said, are Charolais, Limousin, and Simmental. So compared to the British breeds that we just talked about, continental breeds are larger in mature size, but they're later maturing because they do get quite a bit larger than the British breeds. It takes a little bit longer to reach maturity. So they will actually have higher carcass yield, so more saleable product, meat product, but their quality grades will be lower than that of the British breeds. So it's a little bit of a trade-off there. Do you want more product or do you want better quality? And for those things you can think about when you decide which breeds you're going to use. And so continental breeds can actually cause calving difficulties because the British breeds are smaller. If you mate a continental breed to a British breed cow, double, because that calf is going to be a lot bigger than if you had just weighted it to a British breed. So to kind of get a little more specific about some of the more popular breeds, so Angus is extremely popular. There are black and red Angus. The black is more popular. However, there is absolutely no difference whatsoever other than coat color. They have the same meat quality, same characteristics. They just have, like humans, have different hair colors. So the red hair color gene is recessive, so it's not as popular as the black, but no difference between red and black Angus, which I think is very interesting because black Angus is definitely preferred, but no difference there. So Angus are known for good growth and good carcass quality, which is another reason why they're so popular. They also have good mothering ability and milk production. And so mothering ability is, things like they're not going to, have their calf and then kind of not really pay attention to it. Some breeds are better than others at really seeing and protecting their calves and things like that. So that's kind of where the mothering ability comes in. And then also they have good milk production. So because they are a British breed, they have lower birth weights. And so lower birth weights means that you're going to have better calving age. Good growth, like I said. They have a smooth hair coat and are polled, which just means that they don't have horns. And they're not very well adapted to very hot, humid because remember we talked about Bos indicus versus Bos taurus, and they're Bos taurus, so they're not going to do very well in the tropical climate.
Oh, can I ask a question?
Yes.
You talk about there's no real difference between a black Angus and red Angus, but where black is so preferred, so many people are doing more with the breeding and that kind of stuff. Or is there any signs that the improvement in the black Angus is going faster than the improvement for the red, to where ultimately in the next 10, 20 years there would be a significant difference?
That's a really good question. I'm not sure if there's it makes sense because black is preferred. And also black is a lot more common. You don't see quite as many red Angus cows around. So I would say that's probably definitely a possibility.
Yeah, I just didn't know if they've been talking about it there at state while because you're current on what they're talking about, or maybe not so much.
Yeah, and I haven't really, I haven't heard too much about that, but of course, kind of just like dogs would be a good example. You can kind of start selecting for things you want, and then eventually we get farther apart. So I would say that's definitely possible. That was a good question. Now I'm curious. I'll have to look into that. And see what I can find.
Yes, now you have a homework assignment. Good. Did you have a question, Carolyn? Or were you?
Question?
Oh, polled. Do you want to answer that or me?
What polled means?
Yes.
Yeah, so polled just means that they don't have.
They don't have horns. You got cut off there mid-sentence. They don't have horns. Yeah. The poll is the part of the head where the horns grow out. It's called a poll, and so the poll, and then so you poll the cow by getting rid of the horns.
I'm glad I know that a pole was on a horse.
Yes, and that's where the horns grow out, and then and you can breed to have cows that don't have horns to be polled, or you can actually poll them yourself with a saw. Okay, so you can have the steering wheel again.
Okay, no problem. They have a little bit larger size because they're a continental breed. They have efficient feedlot gains and a good amount of saleable product. So again, they'll have lots of meat product, but it may not be quite at the quality level of Angus or some of the British breeds. The light color, because most of them they're white, is better in heat. They don't get as hot as black Angus might. However, with Charolais, there is a risk of double muscling, which is actually this picture on the right. And this is just a genetic mutation that has to do with the gene that controls muscling. And so obviously it can be a big problem because the animal just has so much muscle that it's not really laying down a lot of intramuscular fat, which is that marbling that we talked about earlier. And marbling is really what gives meat a good taste and good quality grade at slaughter. So double muscling is not a good thing. And they're just a little bit more prone to that. Than most.
How strong would that cow be?
How strong would it be?
Yes.
Probably pretty strong. But there are just a lot of issues with it. And it almost like they could have, muscle weighs more than fat. So they could almost even have maybe joint problems and things like that because they are just so heavy. But I would imagine probably pretty strong. I've never seen one in person, but yeah, it's a very interesting thing that happens. So Charolais also have a higher incidence of pink eye because of their light color. More rays kind of could get into their eyes and cause pink eye. They do have high birth weights because they are a larger breed. And so it's really important that you don't breed, these larger breeds like Charolais to heifers like an Angus heifer or something like that because of dystocia, which is that calving difficulty term. So if you breed, a Charolais bull to an Angus heifer, that Charolais, that calf is going to be a lot larger than if you had just bred her to an Angus. And so there could be problems with calving difficulty. So that's really, really important to think about if you are going to kind of crossbreed species. So Hereford is another popular breed, and these can be horned or polled. So horned, and then some don't have horns. They are early maturing, and they have a high rate of gain in feedlot, just like the Charolais do. They have good carcass quality, good calf growth and health. And another thing that they're kind of known for compared to some of the other breeds is a calm disposition. Even the bulls might be a little calmer than bulls of other breeds. They're just what I've kind of heard termed as easy keepers. They're just pretty easy to work with. They're not going to necessarily go tearing up fences and things like that, like some other breeds would. Not to say that they wouldn't do that at all, but just a little less likely. They're not very well adapted to hot climates either. Like the Angus, you wouldn't want to, raise them in a tropical environment. They probably wouldn't do very well. And then like the Charolais, they have a white face, and that can lead to pink eye because of the white face and kind of more UV rays getting in from the sun. Herefords are used in many crossbreeds for their high rate of gain and good carcass quality. And so some of you may have seen a cow that looks like this before. So that's actually an Angus and black Angus and Hereford cross. And so that's what we call a black baldy. So these are pretty common. I see these around quite a bit. And you can also have a red baldy if you cross a Hereford and a red Angus. But red baldies would kind of almost look like a Hereford. But yeah, so that's just so if you see a cow that looks like that, now you know what it's called.
So I have a question relating to the calmness. Are they calm to the point where that would give problems in areas like ours where we have a lot of coyotes? Are they still going to be protective of their young, or are they just completely?
Yeah, I would say they would still definitely be protective of their young because that kind of falls more into the mothering ability category. So they're not going to be so calm in that way. They would definitely still protect their young. So the calm disposition is kind of more when you're handling them, getting them into a chute or getting them onto a trailer and things like that. Just how they are in the pasture, some cows will kind of destroy fences and things like that, especially the bulls. So in those areas, they're just kind of a little bit more calm. But as far as like protecting their young and things, they would still do that.
You can almost think stubbornness and hard-headed. That's half of it there.
Yeah.
Limousine is pretty stubborn and hard-headed, where the Hereford or the Angus, they're pretty laid back and relaxed. But, like any parent or anything, they're going to take care of the kids, and the coyote comes around, they're going to circle. But, you're coming out there acting like you got some sense, they're just going to look at you and be okay with you.
The Charolais not quite that way.
Yeah, Charolais.
They got
yes.
Yeah, my dad got a Charolais, brought it home in the back of a pickup truck with cattle rack on it, and parked it in the driveway. And I thought it was a parked kangaroo. It was trying to jump out. It was ridiculous.
Yeah.
Yeah. And unfortunately, Dwayne last semester called me out because he recognized me from when I was getting towed down the one of the barns at Virginia Tech behind a limousine. I was basically sitting behind a limousine in the back of a barn. And he was there, and he remembered that.
Yeah.
Hard headed.
Both my uncles have Charlet farms, and they get out all the time. They're just constantly like tearing down fences and stuff. So we're gonna now transition into dairy cattle. Before I do that, does anyone have any questions on beef cattle or the breeds that we talked about? Anything?
Why do you put a ring on the bull's nose?
I honestly don't know that has like a real purpose. It might, but does anybody else know that answer? I really don't know, honestly.
It's done quite commonly with dairy bulls because they are so ill-natured, and quite often that ring in the nose, they'll also put a chain in it, and then they electrify the fence on the inside where they have the dairy bull to try to contain those animals. They're extremely violent, and that ring in the nose is an effort to try to reduce the aggressiveness of them, particularly if they put a chain in it and that electric fence. I've seen a highly electrified wire on the interior portion of a lot that had dairy bulls in it, and they'd sling their head and you'd see the sparks fly off the chain when it hit the fence.
Cool.
Thanks. Yeah, I didn't know. I don't have quite that much dairy, so.
Maybe a dumb question. Would you lobotomize a bull to calm down? Would work?
Not when they're natured that way. Not when they're natured that way.
I mean, I would guess theoretically you could, but that'd be a whole lot of trouble and expense.
Yeah.
Just. But.
Any other questions? All right, so we'll talk about dairy. So the little bit of history about dairy cattle. They were cattle domesticated to produce milk for human consumption around about 9,000 BC. And then laws were actually started to be passed to regulate milk quality from 1900 to 1930, which is really important. There are 6 primary breeds that are used in commercial dairies. Holstein and Jersey are kind of the main 2. There's also Brown Swiss, Guernsey, Ayrshire, and Milking Short. So I'm just going to talk about Holsteins and Jerseys just because they are kind of the 2 common ones that you see. So the Holstein breed is originally from Holland, and at mature size they can be up to 1,500 pounds. They're typically black and white in color, and they produce about 24,500 pounds of milk per year, which is a lot. So they're the highest producing breed of dairy cattle. And heifers should be bred by 11 to 14 months of age. So Jerseys originated from.
Leanne, can you roll back that last slide for a couple seconds? A couple people are writing stuff.
Oh, yeah, no problem.
You got it, Flint? Okay, you can go.
Okay.
Thank you.
Yeah, no problem. So Jerseys, that breed originated from Channel Island in Jersey off the coast of France. And they're 950 pounds at mature size, so quite a bit smaller than the 1,500-pound Holstein. And they're typically light gray to a dark, and then they like fawn color to nearly black with a dark face. So this picture kind of shows them that would have that fawn color. And then they produce about 17,000 pounds of milk per year, so a little bit less than the Holsteins produce. And they're actually known for having a high milk fat content. So their milk would have a lot more fat than some other breeds, especially Holstein. They actually have lower maintenance costs, and that's primarily due to their size. And then also due to their size, they have calving ease, so they have a lower rate of kosher calving difficulty. Everyone good on this slide?
Yep.
So dairy production in the U.S., total milk production increased 30% in the last 40 years. And between 1950 and 2008, the number of dairy farms declined with the average herd size increasing. So same kind of thing that we talked about in beef cattle. Number of farms is going down, but the herd size is increasing. So then between 1960 and 2008, the number of milk cows declined by 50% to about 9 million cows, and that was due to increased production per cow. So improved genetics is a big thing there. So if each cow can produce more milk, then you may not need as many cows to reach that goal like you would have in the past. So the number of farms with over 200 cows is increasing dramatically because there are going to farms with more cows on them than number of farms. So some challenges that come with dairy production: it requires a good amount of money to start, so high capital, actually double the amount per cow compared to a beef cattle operation. You need things like land, buildings, silos, machinery, which you would also need for beef cattle production. But for dairy, you need milking equipment also, which is a big thing, and then feed. So dairy management requires very specialized education and training because there's a lot that really goes into it. And producers must follow federal, state, and local regulatory programs. And it can be a very labor-intensive process, and dairy farmers usually have very, very little free time. So if you like milk a lot, thank a dairy farmer when you see it. It's a hard job. So dairy management involves good record systems, and that's really in any system, not just dairy. Record keeping is extremely important, and that can be a very important management tool for the producer. It can provide a decision-making tool on how much concentrate to feed to each cow, when to breed, when to dry off, and which cows to cull, if you're keeping good records on their performance and their age and things like that. Sire selection sources, so you have artificial insemination service, purchase of herd sires, or you could actually raise herd sires. And select herd sires that will improve your genetics. Obviously, you want to select one that has really good. So the top states for milk production are California, Wisconsin, New York, Idaho, and Pennsylvania. And so there are some other ones, and this chart just kind of shows you the percentage. I'm not going to ask you to that. It just kind of shows you the percentage of each of those states and how much they actually are. So as far as dairy nutrition, energy and protein requirements must be met. And again, that's pretty much with any species. In early lactation, there's a high amount of moisture feed. The amount of high moisture feed is reduced because the volume of their intake is going to be limited. So when there's a lot more moisture in the feed, that's just water. So it's kind of diluting the nutrient levels. So if you don't feed as much of the high moisture feed, then they're kind of getting more nutrients, even though they're eating a little bit less. That makes sense. That kind of explain that okay. So during lactation, it's actually really, really hard to meet their nutritional requirements because so much energy is being used for milk production that the animal will actually, some of their body reserves, like any fat that they may have or anything like that, will actually be broken down, and that energy will go towards milk production. So it is really hard to meet their nutritional requirements because milk production is using so much. So something that's really big in the dairy industry is using what's called a total mixed ration, or TMR. So this is actually a blend that combines forages, grains, protein feeds, minerals, vitamins, and feed additives that's formulated to a specific concentration of nutrients into a single feed bag. So that's a picture down there. You can see all of the different ingredients that are in that. So some benefits of feeding a TMR is that your cow can eat a nutrient-balanced ration with every bite. So it minimizes selective feed consumption. So sometimes animals will kind of sift through their feed and eat, certain things that they want. And this kind of reduces that because it's all been really blended together. It can reduce the work of feeding and save labor costs because you don't have to feed different ingredients individually. You can feed them all together at once. However, disadvantages: individual feeding is not possible if you're feeding all of them a TMR and you have a cow that maybe needs a little bit more concentrates or different nutrients. You can't really do that if you're feeding everybody a TMR. You have to kind of figure that out. And it does require a feed mixer and weighing equipment because you would have to mix everything together. So as far as dairy production, the cow is the primary focus. So managing the female, mainly detection of heat is key, and then optimal insemination time, so that AM/PM rule that we talked about. And then management of the male, semen collection for artificial insemination. Bulls can actually be trained to mount dummies for that semen collection. So just making sure that you're getting all of that done properly. So there are some assisted reproductive technologies that are available. So actually over 65% of cows become pregnant using artificial insemination. And so that's just easier because it has many different benefits. One, you don't have to keep a bull around because bulls can be, a little bit more aggressive and kind of cause damages to property and things like that. So you don't have to keep a bull on site. And another thing is if you do have a bull, you're limited to just the genetics of that one bull that you have, if that's all that you have. And with AI, you can actually order semen from many different companies that will have lots of different bulls to choose from. And so it kind of really helps you tailor your goals for your facility. So multiple ovulation is another thing. The cycle of the cow can kind of be controlled so that they can maybe ovulate more than just one egg at a time. So that would increase your chances of them being pregnant. Embryo transfers. Embryos can be transferred from valuable donor cows to a less valuable recipient. So you could have an embryo, like if you have a really great bull that's made into a cow that has really good production qualities, and then you can take that embryo and maybe put it into a cow that doesn't have great production qualities, but it will have the traits of the two parents that you wanted, and then it'll just kind of grow and develop in that cow. That's another thing. And then in vitro fertilization is basically just fertilization that happens in a test tube or a culture dish outside of the cow. And cloning is another one, but that's extremely expensive. So dairy cattle reproduction kind of continued. A little bit about the mammary gland. So like we mentioned earlier, the mammary gland has 4 separate glands called quarters with the teat hanging down from each one. And so cows producing around 29,000 pounds of milk each year would actually produce about 1,000 pounds of milk fat, 1,300 pounds of milk sugar, and 900-ish pounds of milk protein. So making sure that the mammary gland and everything is kept clean is extremely important because something that can be fairly common in dairy cattle is mastitis, which is a persistent inflammatory reaction of the udder tissue to an infection. So you always want to make sure that the teats are being cleaned and that the cows are kept in a very sterile environment. I mean, farm, but as sterile as you can get it to prevent this infection from happening because it can be very painful for the cow and you're not going to be getting good quality milk out of that udder. So that's really important. And this is just a picture kind of showing you what that would look like.
I just did the math there. At 29,000 pounds, that works out to about 80 pounds a day, and at around 8 pounds per gallon, that's gonna be 10 gallons of milk a day that cow is making. Just for perspective, just so you know.
Yeah, no, thanks. So milking procedures and processes, that's the most important job on a dairy farm because obviously the goal is milk production. Cows are milked at regular times. And they know when they're supposed to be milked. I've been on dairy cows before where you actually see the cows start lining up in the pasture and walking towards the milking parlor when it's time for them to be milked. So they know it happens on a regular basis. The street canal must be open to remove milk from the udder. So in the machine milking, we use negative pressure, so it's obviously kind of sucking it out. And then positive pressure to the teat cistern. So there are 2 different milking systems. So there's bucket system and pipeline. So milk quality is extremely important. It determines consumer satisfaction. And it's also really important because if you don't have milk that's really up to sold. So important factors that play into milk quality: herd health, clean animals, clean equipment, and make sure that you cool and store the milk at the proper temperatures so that bacteria can't grow. So there are regulatory programs, biosecurity, and animal health things to consider. So federal, state, and local programs issue permits that actually allow dairies to ship grade A milk. So all fluid milk that's sold for human consumption must be pasteurized to kill disease-causing organisms. And actually something that I've heard of lately is non-pasteurized. People that are on like the organic kick are kind of wanting non-pasteurized, although I'm not really sure why. Then biosecurity is really important to reduce the risk of introducing new pathogens to a dairy herd and reduce the spread of pathogens within a herd. And then again, mastitis, which we just talked about, it can interfere with the normal flow of milk and milk quality, and it can cost the industry more than $2 billion per year. So it's kind of a big issue in the dairy industry that needs to make sure that you're trying to prevent it. The knowledge of dairy cow behavior, or cow sense, is necessary for the successful management. You want to know how your cows are going to behave so you can better manage them, and also notice if one of them is behaving differently than it normally does, and maybe it's sick or something like going on. Cattle communicate by using sound, odor, visual displays, sight, and then welfare of cows obviously leads to improved production and income. So if your cows are living a good life, they're not stressed, they're going to do well, produce a lot of milk. So dairy cows, just like other animals, can get stressed. And stress can be caused by things like changing their feeder, water, space, housing, or herd mates, any sort of change. The number of animals that are housed together, transportation, strange people, fatigue, infection, management practices, if you're not really managing them properly or handling them correctly. Weaning can be kind of stressful. Temperature changes and abrupt weather changes can all cause stress to the dairy cow. The dairy cow facilities are designed for the comfort and health and productivity of the cows. Important things to consider are ventilation, quality and accessibility of feed, lighting, and cow comfort. And housing systems can actually differ by life stage. So you may have stall barns, or you may have loose housing. So this is just a picture of a milking facility that might be fairly common in the industry. So you have milking parlors, and you can have stall milking. So you can assess cow comfort using the cow's behavior as a guide. And then another important part of the dairy production is manure management. So you want to make sure that you're following sanitary and pollution control regulations. And you want proper facility design because that, if you really put thought into the design early on, that can save you a lot of hassle later on. So how dairy cows are managed, the practices can vary by cattle and by their stage. So you have pre-weaned calves, replacement heifers, dry cows, transition cows that have metabolic disorders, and lactating cows. You would manage each of those differently, so I'm just going to touch on a little bit of so for pre-weaned calves, the first day of life is extremely critical. They must get the antibodies from that colostrum that we talked about to get their passive immunity. And 80% of calf deaths are actually related to dystocia. So trying to really prevent that in any ways that you can. Calves should be kept in a thermally neutral environment, so between 50 and 75 degrees Fahrenheit, and usually full of earth. And they're typically kept in hutches for about 3 months. So that's just what. So for replacement heifers in the U.S., sold, and that really depends on how well they are producing. And then dairy producers should replace about 1/3 of their herd each year to keep up. Cows will be killed if they're less profitable, or if they are starting to experience reproductive failure. So well-grown heifers are bred at about 14 months old. Early breeding of heifers is more profitable because it will shorten the time from their birth to their first lactation, and it will reduce your feed costs to maintain that animal. So then for lactating cows, milk production needs to be optimized for early lactation because that's when you're going to really get the most. Rations should maximize dry matter and nutrient intake, which we'll kind of go more into that when we actually cover the nutrition chapter. And like I said, cows in early lactation have a negative energy balance because their body reserves are actually being used to provide energy for milk production. So it's very, very hard to get them enough energy. So you can't meet the nutritional requirements through feed intake. So some lactating cows may have a loss of body condition score. And so that's just the kind of score that you would want them to have in 5 scale. And fresh water should always be available. For every pound of milk that's produced, the cow needs to consume 4 pounds of water. So they always need to have water available. And this is just a chart you can look at later. So for dairy cattle, this 1 to 5 scale is pretty common, and that just shows you for each stage where they should be body condition wise. And then this picture just kind of shows you what those would look like. So you would kind of want somewhere between a 3 and a 4. And that's all I have for today. Any questions? And it's getting close to time for y'all, but any questions before you leave? Good. All right. Well, y'all have a good rest of the day.
Bye, everybody. See y'all. Some of you tomorrow, some of you Thursday.
We won't have class either. When any of the schools is out, we're all out.
Okay.
I gotta look, we'll have a similar date, but I'm not sure.
Okay, bye.
Oh, we